So we have understood the behavior of trigonometric functions as we looked at the unit circle, and we also know some chief trigonometric identities, and so all of this will help us solve trigonometric equations. So here I have an equation here. So 2 cosine of 3t, 3t meaning the angle here, minus 1 is equal to 0. And so we have to solve this. Now looking at this, obviously we can add 1 to both sides. So we're left with 2 cosine of 3t is equal to 1. And dividing both sides by 2, we get cosine of 3t is equal to 1/2. And so this is quite interesting because if we look at the 3t here, if this was one particular angle, say x or theta, then you can obviously determine that value because we know, the cosine of a particular angle giving us 1/2. We know that's pi over 3. Again, in quadrant 1 because it's giving us a positive value. So if we know that's pi over 3, we also know that quadrant 4 here is applicable because cosine value in quadrant 4 is also positive as all students take calculus. And so really, if we know that, then we would multiply 3 by 2 and subtract 1. So we would also say that 5 pi over 3 is applicable as well here. But we don't want to really do that because we have 3t. So we will be doing that, but first we have to assume 3t to be a certain variable. So we can just assume that, take any variable such as x. So say assume x is equal to 3t, and now the problem becomes easier because you're really seeing cosine of x is equal to 1/2. So now you have this, right? And now when you solve for it, you're really taking the inverse, I guess you could say. So when you write this, you're seeing cosine of cosine negative 1 1/2 is equal to x, and this is not to be confused with the reciprocal, -1 when it's raised. Obviously when it's in the exponent form, people think that this is 1 over cosine of x, but this is not symbolizing secant. What this means is the inverse, which means that if this is a given ratio, for which particular angle are you getting this ratio? So it's saying cosine -1 of 1/2 is giving you which angle. So this essentially means that cosine of x should be giving you 1/2, but you can write this as this to solve for that given angle, which is x in this case. So that's just a notation, but just don't confuse this with 1 over cosine of x. So looking at this now, we know that x could be pi over 3, or it could be one solution is pi over 3 and the other one is 5 pi over 3. So these are the two solutions. Now what's important is that, because you're really determining what t is in this case, you have to understand that the unit circle is really a circle that revolves, and so you have infinite number of angles. So when we want to solve for t, what we're really gonna do is we're gonna say pi over 3 plus 2 pi n should give us 3t, and 5 pi over 3 plus 2 pi n should give us 3t. And so the reason why it happens to be like this is here n could be really anything. So it's just an integer that you're substituting values in, and it's giving you 3t because you know that these two values are the values for x here, which represents 3t. But the fact that it represents 3t indicates that t will definitely be a smaller value. And if we want to see exactly which all values exist so that we don't miss any, we have to do plus 2 pi n to get as many values as we possibly can. So, and where n is just an integer. So if we solve both of these equations further, we see that. So what you can really do is you can divide both equations by 3 to isolate the t. So you get t from the first equation, t is equal to pi over 9 plus 2 pi n 2 pi n over 3. And so if you want, then obviously using the common denominator, you can say t is equal to pi plus, and then multiplying 2 pi n by 3, we get 6 pi n, right? Pi plus 6 pi n over 9. So really we have this, and so we have this. Similarly, we would do the same thing for the other equation, and so we divide both sides by 3 again. Here, let me just do it over here. So we do this. We divide both sides by 3, so we get t is equal to 5 pi over 9 plus 2 pi n over 3. And so now we look at this, and we know that again 2 pi n over 3. So this is we can just write this as to the common denominator. So we could say 6 pi n over 9. So and obviously we can write this as 5 pi plus 6 pi n over 9. So these are the two equations that we have for t. Now I'll just erase this quickly so I can get more space here. So our two equations that we got for t, right? Those equations were, so t is equal to pi plus 6 pi n over 9, and t is equal to 5 pi plus 6 pi n over 9. So these are the two equations we got. Now the thing is, again, I told you n's any integer. Now to get all the values, let's just substitute in integers, obviously, in for n to determine possible values for t. So if we substitute 0 in for n, we see we're left with one of our answers. It's obviously pi over 9. We place in 0 here. We see 5 pi over 9, right? And now we can place in 1, right? So we get again, we place 1 here, so we get 7 pi over 9. We place 1 here, so we get 11 pi over 9. Now we can plug 2 in here. That gives us 13 pi over 9. And then substituting 2 here gives us 17 pi over 9. And now if you were to substitute 3 in for n, we would get 19 pi over 9, and clearly 18 pi over 9 is 2 pi, and if we were to substitute 3 in, 19 pi over 9 indicates that it's not within that range of 2 pi. So we have to make sure that it has to be obviously less than 8 pi over 9. So these are possible values here. And the best thing about it is, of course, you can plug these values into your calculator in for t, and then see that all of these solutions really match with the equation that we originally had. So this is how you do it. So again, the main concept is that you're just solving as you would do for a regular equation. And then you always want to take the 3t, 6t, 9t and substitute that as x, determine the values for x, and then once you get those values, you want to do plus 2 pi n is equal to that original value that you had. So for instance, the value you got plus 2 pi n is equal to 6t or 9t, and then you solve for t from there, and then n is really where you're substituting values in, and you want to make sure that it falls in that range, in that domain. So really it has to be between it has to be less than 2 pi, obviously. So these are our possible values for t in this problem here. So I have another equation here. This one is not with angles, but this one's a different type of equation involving more of the identities that I had gone over in the previous lesson. So here the equation I have is the equation I have is secant square x minus 2 tangent x is equal to 4. So if we think about this, do you recall what secant square x was? Because again, if we were to solve this as either a linear equation or a quadratic equation, because we know there's a power of 2, I mean, it's always better to have the same trigonometric function present in the equation to make it easier. So we know that the identity states, the Pythagorean identity that we had derived earlier, states that secant square x is equal to 1 plus, so it's 1 plus tangent square x. Now that's what secant square x is. Minus 2 tangent x is equal to 4. Now if we look at this, and we can just say, I mean, I know it doesn't make sense if we say tangent of x is equal to x, but in our minds we can assume that tangent of x, I don't know, is something. Just say it's y, z, say it's z or something like that. So if tangent of x is z, it will make sense to say 1 plus z squared minus 2z is equal to 4, but you can move the 4 here, so minus 4 is equal to 0, really bringing this into the quadratic form because we have the degree 2 here. And so obviously if we simplify this, we get z squared minus 2z minus 3 is equal to 0. So now we look at this, and obviously when we factor, we see z minus 3 times z plus 1 is equal to 0 again, because negative 3 plus 1, right, have a product of negative 3 and their sum is negative 2, so this is what satisfies it. And now we know that z is tangent of x, really, so we can just substitute that back in. So we have tangent of x minus 3 times by tangent of x plus 1 is equal to 0. This is what we have now, and really it's really similar to how you would solve a normal quadratic equation, because you have set everything to 0, and really this can be 0 if either this factor is 0 or this factor is 0. So if you were to set this factor to 0, you would say that tangent of x is equal to 3, and then the other one will be tangent of x is equal to negative 1. Really, again, with this concept here, tangent of x is equal to 3, what you can really do is here on the calculator, obviously, so you have, you can just do second tangent, right, and then you can substitute, or just press in the value 3 here, and so you do that, and when you do this, you get 71.6 degrees here as your value, as a possible value for x. And for tangent of x is equal to negative 1, you really don't have to use the calculator, because it's something that you should know, because we already have gone over the unit circle. So really, if you think about it, tangent of pi over 4 is 1, right? But we're looking at negative 1. So in which quadrants is tangent negative? That should be your first question. Clearly, all students take calculus. In the first quadrant, every function is positive, and all students take indicates that in the third quadrant, tangent's positive. So it's the second quadrant and the fourth quadrant that have negative values for tangent. So we know pi over 4 is the reference angle, and we know that the second quadrant has a negative value. Right, the rule is the numerator has to be 1 less than the denominator. So we know that it's 3 pi over 4, and the other value will be in the fourth quadrant. So that again, you'll multiply the denominator by 2 and subtract 1 from it, and you'll get 7 pi over 4. I know I have these two values in radians and this one in degrees, but you get the idea of these three values being the solution here. So again, because usually when you see something being negative 1, you always want to recall that most likely you're looking at two quadrants, because really if you have a positive value here, you know that the first quadrant has positive values for any function really, and then it's likely that there will be one other quadrant that has the positive value, which means that if there was a negative value, you're looking for two solutions for that x. So in this case, tangent of x is equal to negative 1 gives you those two values here. And so here tangent of x is equal to 3 gives you 71.6 degrees. But now when I think about this again, I may have made a mistake actually, because if this value is true, this is true because we got this from quadrant 1. But really, if we think about this, tangent of x is equal to 3, so we should be getting 4 values because we got something that was positive and negative. So I actually missed out one value because these two values that I got were for a negative for -1, and 71.6 degrees was for the positive for positive 3. So if there's a positive value here, we should understand that in the third quadrant, really, we can get the positive 3 here. So if I make the triangle here in the third quadrant, and I know my reference angle is obviously 71.6 degrees. We know that this angle over here is 71.6 degrees, something like that. And just knowing that, we know that in the third quadrant, obviously, it's going to give us a positive value. Therefore, there's another value here. You would get the idea that this is 180 degrees. So our fourth possible answer is 180 plus 71.6 degrees. And if you put this in the calculator, you should get 251.6 degrees as your fourth possible solution. So I actually missed out one, so you will see that there are 4 answers to this problem. So thanks for watching.